Hello again. I'm Mike Robichaux for Long McQuade, here to answer some of the top unanswered questions from our stream on Friday, which you can still check out on the Facebook page if you want the deep dive where we started last week. This will be just following up and answering a few of the questions that we didn't really get to. Okay, so first thing that was kind of asked was a little more just about cleaning, oiling fingerboards, polishing frets, and restringing. So I'm going to show you all that on this J45. I'm going to restring it really quickly for you. I'm going to take all the strings off, clean the guitar, show you how I clean and oil a fingerboard, how we clean the body, and then I'll just quickly put one string back on and show you real fast. So let's do that. Just going to take all the tension off the strings. One thing we get asked sometimes is it okay to take all the strings off at once? 100% yes. It is perfectly fine to take all the strings off of the guitar at once. It's not going to put the guitar in any danger or run any risk. If you want the deep dive explanation, I do talk about it somewhere on the Friday stream. It's acoustic guitar. We're just going to pull the bridge pins out here carefully. If bridge pins ever really stuck in the guitar, what I'm doing here, this is kind of a guitar technician's trick. I'm using my cutters, my actual wire cutters, and I'm very, very carefully just using it to pry out the bridge pin. Here, I can maybe show you a little bit more in the camera 3. I'm actually coming in from behind with the cutters open and just using it to apply a little pressure and lever the bridge pin out. As long as I'm not actually closing the cutter down on the pin, I'm not going to cut it off, and I can just use it like a plier to pull it out. Take all the strings off. Makes it much easier to clean the fingerboard. Makes it a lot easier to clean the area in front of the bridge before the sound hole. Okay. So the first thing we're going to do is clean up the fingerboard. This fingerboard is not very dirty. This is a rental guitar that is going to be put back out into the fleet. One thing I talked about very briefly on Friday was scraping fingerboards. If you do have a lot of buildup, a lot of gunk on there, kind of fingerboard that hasn't been cleaned in a while, you can scrape the bare wood of the fingerboard as long as it's a bare wood fingerboard and not a finished one like a maple. I talked about these little plastic razor blades that you can buy we buy them at Lee Valley. I'm not sure where else you can buy them. These are actually great. You can use it to just scrape the fingerboard. If you do have any gunk, you can push as hard as you want. You're not going to leave an actual scratch, but it's enough that you can really scrape the fingerboard clean if you have to, if it's really, really dirty. On a slightly less gross note, once you do have a reasonably clean fingerboard, actually I'll show you one other thing real quick. The way I clean fingerboards, generally speaking, I don't do a lot of scraping, as I mentioned. I prefer really to just use elbow grease and scrub. So if you have anything but the dirtiest of fingerboards, I use lemon oil. It's oil, it treats the fingerboard, but it also cleans the fingerboard. And I'm going to put a fair bit on here. Don't be terrified. Okay, that qualifies as a lot of fingerboard oil. It's actually kind of wet. I can push it around. There's standing liquid on the fingerboard. Some people are screaming at me right now, but it's okay. I only do this when I'm going to clean the fingerboard, and I do it, and I use it really as a cleaning agent, and you can really get in and scrub the fingerboard. This is just an old t-shirt cotton rag. You can do this with paper towel. The truth is, when I have a really dirty fingerboard in the shop, I'll usually do this step with paper towel and kind of replenish the paper towel a few times. That way you can really carry any grime or anything that's coming up off the fingerboard away. So this is how I clean fingerboards. So that was a lot of oil to use on a bare fingerboard, but the key here is that I've scrubbed it hard and I've wiped away 100% of the excess. So that was really an extremely, extremely little amount of oil that was actually left on the fingerboard, but it's enough that it can absorb. Wouldn't be the worst thing if I'd let that stand for a few, a minute or two, but you never want to leave sitting water, real sitting liquid on the fingerboard. It can swell the wood up in uneven ways, gets in around the frets, it can cause loose frets, things like that. Okay, so that's a nicely cleaned fingerboard. I've just used the lemon oil to clean it off. Let's talk a little bit about steel wool, about other ways you can clean your fingerboard. One thing that a lot of people do every time they have their string, maybe not every time, but sometimes if you really want to clean up and refresh a fingerboard, I had a question there from Ivan. Do we use the same kind of oil for rosewood or ebony? Yes. Yeah. Any linseed oil, lemon oil is kind of the industry standard. That's what's sold as guitar products. Same thing for ebony or rosewood fingerboards. Use even more sparingly on ebony. Ebony really doesn't absorb much oil, doesn't really need much. So very quickly, in terms of cleaning your frets, you can use steel wool if you have corrosion on your frets, if they're a little bit scratched up, if they have very minor scratching, anything like that. You can use steel wool. It's very common in the industry. Some people move away from it because it gets attracted to metals and so forth, but it is pretty common to use steel wool. The only kind of steel wool you can use on a guitar that I recommend you take anywhere near your guitar is quadruple zero. Generally they're 0, 00, 000. Quadruple zero is the type of steel wool you want to get. It's basically the finest gauge. It's actually used in finishing, painting purposes. It's safe enough that you can use on a fingerboard. And I recommend, again, getting oil-free steel wool. You'll generally find this in carpentry stores, painting stores, things like that, specialty wood suppliers. Less so what you're going to find at Sobeys in the kitchen cleaning aisle. This is a product that's made for woodworking and wood finishing. So quadruple zero oil-free steel wool is what you want to use on your guitar. If you have major corrosion on some of your frets, which these frets really don't, but it should be enough that I can show you a little bit of a difference here as I go. I'm going to actually go right across the fret like this. And you'll notice I'm not using any kind of guard. I'm not protecting the fingerboard. I'm just coming right in with the quadruple O steel wool. This is safe to do with quadruple O. You're not going to put scratches in the fingerboard. You're not going to cause any problems by going right in without any kind of guard on the fingerboard. Let's just see if I have one of those that I can show you real quick. Darn, okay. Oh yeah, here we go. So this is a fingerboard guard. It's just a piece of metal and I have some extra tape to make it a little wider. It protects the fingerboard so that you're only getting the steel wool on there. You generally don't need to do that with this stuff because it is so fine. You'd usually only use a guard if you're going in with a rougher steel wool. If you have actual rust on your frets or things are really, really damaged, you can come in with something a little more aggressive and you may want to use a guard. But it's not necessary if you're using the quadruple O. If you do this regularly, even a couple times a year, this is all you'll ever need. So you can get in, polish up your frets. You get any scratches out of them. This kind of lateral polishing along the length of the fret is going to help with fret buzz and fret scraping when you're bending. And then the last step for the fingerboard is you can do some longitudinal strokes with the quadruple O steel wool. This just means any micro scratches, any like fine, tiny little like swirls or scratches you put in the fingerboard are going to run the length, the grain of the wood. It's going to look a lot better, and this is the final step. For a lot of factories, Taylor guitars, Martin guitar, this is the only way they clean fingerboards, is just by going all the way up and down the length. Gives you a nice clean surface. And then when you're done with that, if you want, you can do one more quick clean with a very light streak of lemon oil, just to hydrate it. And then your fingerboard's nice and clean. And that's the most cleaning you should ever do. There are questions about what other cleaners can be used. On fingerboards, I really wouldn't recommend using anything other than a lemon oil or a linseed oil, which is what is recommended for this stuff. You do see neck wax. Some people even use other type of waxes that are meant for cutting boards or salad bowls or things like that. I really don't recommend that. Wax starts to do very strange things with finishes. And any household cleaners you should generally keep away from your guitar. For the most part, most guitars it's fine to use water and just a very basic dish soap to clean them, but you need to completely rinse and clean the guitar and get any last molecule of water off of it if you want to go that route. So I just recommend spending the $4 or $5, getting a bottle of guitar cleaner that is made for guitars, and then you'll never have to worry about it. So on to that step, I've got a little bottle of guitar cleaner. This is Planet Waves, but every company makes a guitar cleaner, and there's many different options out there. One last thing I want to say about the steel wool, it does kind of get everywhere. If we were in my shop, this would all be vacuumed up by now, but for everything I brought, I did not bring a vacuum, so we've got a little bit of steel wool kicking around here. So real quick, I'm just going to show you how to clean a guitar. There's kind of two ways you can clean a guitar. You can use just a microfiber cloth. This is like a glasses cleaning cloth kind of idea. They're sold as guitar polishing cloths generally. This is an Ernie Ball microfiber cloth, but most guitar care companies make them. Actually, I had a good question there. What about maple fingerboards? Is lemon oil okay? No. Maple fingerboards are finished, so everything about the fingerboard can basically be disregarded. You're just going to treat it like the finish elsewhere on the body of the guitar. So everything I'm going to say about the body of the guitar applies to a maple fingerboard. Don't use oil on a maple fingerboard. And if you do want to steel wool the frets, make sure you use some kind of guard, or you can even just tape off the fingerboard with masking tape to protect that finish, because the finish is going to behave differently than bare wood. So cleaning the guitar, first easiest way is with a microfiber cloth. This has nothing on it. These cloths are not meant really to be used with a cleaner. They're meant to be used dry for a not very soiled guitar. You can use a little bit of elbow grease. We've all done this. This is like cleaning off your cell phone or cleaning off your a monitor on your laptop or something like that. It takes a little bit of elbow grease, but the microfiber cloth is going to pick up all of the grease, all of the oils, everything that are on the body of the guitar, and it's going to leave nothing behind. This is really the safest way to clean a guitar. There's basically nothing you could possibly do to damage a guitar just cleaning with a dry microfiber cloth. As long as there's no little scraps or anything that you drag across to cause a scratch, as long as you don't rub so hard that you actually build up heat, which would be basically impossible, there's no real way you can hurt a finish with a microfiber cloth like this. However, these things do get a little loaded up. Anyone who's tried to clean their glasses with a very dirty glasses cloth knows at a certain point, a certain amount of grime these things just can't handle. So that's where a guitar cleaner comes in. This will generally be marketed as a guitar cleaner or a guitar polish. It's going to be a liquidy, water-like substance. It's not a paste or a cream. And this is meant for cleaning, loosening up and cleaning grime off the guitar. So just a light spray on the cloth. Don't spray it on the body of the guitar. It gets it down inside. It gets a little bit too much volume on. It's too concentrated in certain areas. Remember, these finishes, they do dry out, they stretch, they move. They're not exactly living things, but they almost behave like it. So you do want to be careful about actually never spray the polish right on the guitar. Always on the cloth. You want the cloth to just kind of be damp. And so again, you can kind of work different areas if you have particular lots of fingerprints or lots of grime built up. If you really are cleaning an old guitar that is grubby, like especially a lot of times in the armpit area here, you get really just kind of like human buildup. You can put a little high intensity on there and really go at it and kind of do the cleaning the only real technique I can give you for cleaning really grimy areas is you are almost kind of trying to like scoop it off like that and get it into a dirty spot on the cloth, then go to a clean spot. You may need to use a few cloths. We use these lint-free cleaning cloths in the shop. They're disposable, but they're almost reusable. They're really tough. The nice thing about them is if we get a really dirty guitar, we can use a few of them and go through them, throw them out when they get dirty. As soon as your cloth is a bit dirty, you're not doing any good using it on your guitar, no matter how much cleaner you introduce to the situation. So one last thing real quick for cleaning guitars. You might see guitar wax. There were some questions about guitar wax. Guitar wax is not necessary. If you've cleaned your guitar, you don't need to wax it. If it's a matte finish guitar especially, a flat finish, do not wax it. Do not, because it will shine the guitar. But if you have a glossy finish like on this J45, a layer of protective wax will help. It puts some nutrients into the finish. It keeps it flexible. It'll help it from drying out and going brittle over time, and it will protect it and make it look really, really shiny. The only thing I want to communicate here, you could do a whole video on waxing guitars. Do remember, like the Karate Kid, it's wax on, wax off. The wax does not stay on the guitar. So put a little bit of wax on the cloth, come in, start waxing one area, and you notice you've added a buildup. Unlike the cleaner, you're adding something to the guitar. You can clearly see where the wax leaves a swirly spot where you've waxed. You rub it in for a little bit, you polish out any imperfections, you work it into the finish. This should take some elbow grease. And then from here, that's wax on. Now wax off, we're going to use a clean part of the cloth or just a whole new cloth altogether. We're going to come at it again, and now it slides really smooth because all we're doing is just taking that top layer of wax off, getting all of that off. and it's just leaving what we've really forced into the finish, and now there's no grimy residue left on the guitar. I don't know how well we can see it in the spot that we just cleaned. That'll be a tough thing to get on camera. This really is in person. You can see the massive amount of swirling and damage on the back of this guitar's finish. So it's an area that probably needs a little more serious sanding and buffing to ever get it to look perfect. Okay, so that's the most important thing with wax, is that it has to come off of the guitar to really do what it's supposed to do. If you leave it on the guitar, it's just going to be a sticky residue that attracts dust and is going to do more harm than good and make your finish dirtier after a couple of days than it was to begin with. Okay, so that is cleaning the guitar super fast. I'm going to put one string on this guitar just to show everybody. Again, we did a big series of these where I change a string on a whole bunch of different types of guitars and really go into my kind of finer thoughts on all of it. So if you're hoping for some info on changing strings, Matt's going to post the link now or soon, and you can check those videos out. String changing is one of those things that seems simple, and it is, but there's a lot of extra info, and I like to make sure everyone has all the information, so those videos are where you should go for that. But real quick here, for an acoustic guitar, once we've taken everything out, acoustic guitars probably have the only real trick you need to know is that the ball end of the string, here we'll do it on this camera, the ball end of the string should have a bit of a curve in it, right? You don't want to put it in just perfectly straight, because you want it to actually go down below the plane of the guitar's top, and it's actually going to curl underneath, and then the bridge pin comes in behind it and hooks it in place. So I'll show you what I mean there. What you don't want to have happen is have the ball end of the string sitting on the end of the bridge pin so that it can pop it out. So that's why that curl will help get it a little more in place. Put it down inside the guitar, put the pin in, and now holding the pin in place, pull the string to make sure it's seated. Make sure it's seated properly. At this point, you should be able to yank on that thing all you want without popping the pin out. That's how I know that the ball end is seated properly against the guitar's top, and it's not perched on the end of the bridge pin. There's more on that in the videos we recorded. So you come up here to the headstock. There's a million opinions on the right way to put a string on at the headstock. I'll show you the simplest way that we do it in the repair shop in Toronto. Bring it through. How many winds should we get? Generally on the bass strings you want 2 to 3 winds. On the treble strings, the plain strings, you want more in the area of 4 to 5 winds around the post. So a good way to measure that on the bass strings, the wound strings, pull it basically tight, grab the string at the nut, pull it back 2 frets, and then that's about the right amount of slack that you want for the wound strings. And if you're doing a plain string like the high E, same thing, but just pull it back 3 frets. And 2 frets for wound strings, 3 frets for plain strings. That'll generally get you in the right neighborhood for windings. There's a bunch of little factors, the type of tuners, the type of headstock, but for the most part, that'll get you close enough. So for this wound string, I'm going to pull it basically tight, pull it back 2 frets. That's my proper amount of slack. And now I'm just going to start winding it up. And at first, I'm going to wind it over the tail. So this tail that comes out, my string's going on top of it. And now, after I've gone on top of it once, now I'm going to bring it down below. And now I'm going to go down below that tail. So now you can kind of see that I've got my first winding on the top, and now all the subsequent windings are going to be below it. So that I'm winding down towards the headstock, not up off the top of the tuner. If you use a power winder or a handheld string winder, which I have here somewhere, if you use a handheld power winder, a handheld string winder, always wind it up to pitch by hand. At the end. And then before you cut it off, generally speaking, you can cut the string off as short as you want. It's not a bad idea to give it a little bit of a bend, just so that it doesn't slip back through, locks it into place a little bit more firmly. And then you can clip it off relatively short enough so it doesn't stick over the top of the peg head. Talking tools, by the way, just real quickly, what kind of tools do I need to cut guitar strings? You do need something that's made for hardened steel. If you use end cutters or a lot of wire cutters that are just made for cutting electrical wires, stuff that's sold in the computer repair industry and so forth, it's not going to be strong enough for steel guitar strings, and the tool is going to break and become ineffective very, very, very quickly. In the shop, we use really, really high-end cutters, but that is not necessary. Again, this is my own personal tool. These are my personal wire cutters I have owned for almost 2 decades. They are Mastercraft. I bought them from Canadian Tire. I don't remember what I paid for them, but there's no way it was more than $5 because I was darn cheap back then. The blades on these things are still flawless. I've never used them for anything other than guitar strings. So you just got to make sure that you do get hardened steel cutters that are meant for cutting steel wire, and you don't need to spend a lot of money. Okay, so that's one string on there. You bring it up to pitch. I could talk about restringing all day, but we shall move on. There's lots more info in the videos. Okay, now we're going to talk about intonation. We're going to take out this SG. So I talked a fair bit about intonation. Intonation is a masterclass, right? I mean, you could do a whole video series just on intonating guitars. In everything I talked about yesterday, I didn't really show a good example of the process, so I'm just going to very quickly show that. Just get a little volume so we can hear as well as see. Okay, so now I've got my strobe tuner here. You can use any kind of tuner to do intonation, but a strobe tuner is definitely going to get you the best results. Just bring that in a tiny little bit. Okay, so on our SG here, this has a 2-pneumatic bridge. And so the saddles go back and forth, maybe just by adjusting the slot-headed screw. I'll move this one more time. Maybe if we can get camera 3 up here, just sort of show how this works in real close-up. So the way this works, pretty straightforward. Tightening the screw brings the saddle forward, brings it towards the front of the bridge, and it makes the string shorter. As I tighten the screw, brings the saddle forward, and it's making the string shorter is the key. Opposite, if I loosen the screw, it's going to bring the saddle, send the saddle backwards, and it's going to make my string longer. So ultimately, that's what you have control over. When you are adjusting intonation, what you are adjusting is the length of the string. In fact, deep in parts land, a lot of times these screws are called saddle length screws or string length screws, which confuses a lot of people. But that's what you're doing when you're adjusting intonation, is you're making the string shorter or longer. So the same way how acoustic guitar bridges are sloped backwards a little bit so that the bass string is longer and the treble string is shorter, on electric guitars, it's giving you the same control where you can choose which strings you want to be longer or shorter, but it's giving you much more adjustment. There was a question that was asked, one that I wanted to make sure I answered, about these 2-pneumatic bridges. This is, of course, a design that Gibson's been using for pretty much since the start of their solid body electrics, at least. And do the screws face forward towards the neck, like on this guitar, or do they face backwards towards the bridge? On this guitar, the adjustment's right here. You come in from the neck, but often you will see them where the adjustment is in the back. The answer is, well, even Gibson would tell you it's a little bit up in the air. The original patent for this bridge does show the screws in the back, actually, so the opposite of the way this is set up. So historically, the original patent from Gibson says that the screws go in the back. That said, almost all of these bridges, you will find them set up with the screws in the front, including direct from the Gibson factory now. Really, it's a superior way to do it. It's a little bit easier to get in at the screws. You're not having to fight with the break angle of the strings. There's just a little more space for the tool, frankly. And then also, kind of one last concept to understand is you do have break angle here. So if we're looking at camera 3, you can see that the strings, as they break behind the saddle, they actually come pretty close here. They don't touch the saddle, but they do come close to touching it. If we had screws sticking out the back here, it would make it even harder. We'd have to raise the tailpiece. We'd have less room. So functionally speaking, 100% the saddles should be in the front, facing the neck. That is the easiest way to adjust your guitar. But the original, historically, they were in the back. The last thing ultimately I would say is if you are setting up your own guitar, flipping things around, just keep in mind these saddles usually are cut for the specific string. So the bass saddles have a much wider cut to accommodate the larger strings, whereas the treble strings, it's a much narrower cut. So however your guitar came cut, that's the way you want to set it up. You can't, if your bridge is one way, don't just flip it around to make it easier to adjust, because you have to be mindful of the way the saddles are cut. In fact, sometimes, you know, you get an old guitar, maybe that didn't have strings on it, you got all the parts in a bag, you can sometimes tell which way the bridge was oriented just by how the saddles are opened up. I got a question here. What's your thoughts on certain guitar cleaners costing plastic pick guards to get distorted? Yes, so a lot of times on electric guitars like this Stratocaster here, this pick guard, not so much on this model, but sometimes you do see these pick guards becoming wavy and kind of turning into a potato chip over time. It doesn't have much to do with the cleaners. Maybe some very old nitrocellulose pick guards, you could definitely have problems with cleaners, with certain cleaners breaking down nitro, but you don't really see nitrocellulose pick guards anymore. Most of those problems with a pick guard becoming distorted are caused by two things. It's either frankly inferior manufacturing. Usually you see that with laminated pick guards where there's 3 or 5 layers, one of them's white, one of them's black, one of them's tortoiseshell, and something about the way those layers shrink or swell differently just didn't cooperate, something like that, and you see it warping, and that's usually a manufacturer defect, and if it's coming from a reputable brand, usually they'll just replace that, no problem. The other reason you see pick guards get distorted that is usually more in the owner's ballpark is humidity. As we talked a long time on Friday about humidity, doesn't affect electric guitars quite as much, but this is one way it can. If your body shrinks and swells a little bit, the plastic, the pick guard doesn't shrink and swell, so the screw holes, as the wood is shrinking and swelling, the screw holes where it's mounted are getting closer together or further apart, but the plastic can't move, and so that causes some distortion. Why have slack before twisting the tuning pegs? Yeah, so when I did the restring there, the truth is when I'm doing it in the shop, I'll usually wind the first winding around by hand, but you have to have some slack so that you get enough windings. You have to have enough wraps going around the post, because really the only thing holding that string on there is friction. Old tuning pegs on really old instruments didn't even have the hole, actually. You literally were just doing a lasso style Indiana Jones, wrapping it around enough times that when you pulled it tight, there was just too much friction, all the windings tighten up on themselves, and that's what keeps it from slipping. The windings are critical for keeping good tuning stability, by the way. If you're having tuning issues, a guitar slipping out of tune, not having enough windings on the post is by far the most common and simplest thing that we see that causes tuning issues, and it's just slipping. There's not enough wraps, there's not enough friction. Okay, so I showed quickly how this bridge works, back to intonation. So we have, by adjusting the screw, we can go back and forth and make the string shorter or longer. And most adjustable bridges are some variation on this that makes the string shorter or longer. So the basic principle of intonation is that you're adding compensation to the string, which is that you're making it longer. That's usually how we talk about it, is compensation is that extra length we're adding. Beyond what the math says about exactly where the 12th fret should be and exactly where the bridge should be, we add a little bit of extra length to the string called compensation to get it to play in tune. And what it's compensating for, the thing that compensation is compensating for, is that when you press the string down, you stretch the string a little bit further. So even though mathematically on a computer these are all laid out perfectly, the 12th fret is exactly where it should be, and the string, a string of this length should play perfectly in tune. But what the math doesn't factor in is how much that string is going to stretch and shift up in pitch just by pressing it down for the fret. So we lengthen the string a little bit beyond where it should be. That's called compensation, and that's to compensate for the extra unintended stretching that goes on. So looking on my tuner here that I have on camera 3, this is a strobe tuner. And the way these work, if you're not familiar with it, the rings spinning around represent the partial frequencies. They want to be still. So right now I'm playing my open A string, and it is almost dead in tune, just rolling the tiniest bit flat there. These are incredibly sensitive tuners. This is not usually what people use on stage. This is mostly just for setup purposes. You can do this whole process with any tuner, by the way. Just strobe tuners are what we use in the shop, and they're a little more accurate. So this is just about close enough. It's just rolling a hair flat of in tune, but if I bring it up a tiny bit, I want to get this nice and close for you. Okay, there we go. So that's an A in tune. Now I'm going to play the A at the 12th fret. And you can see it's way sharp. It's rolling a lot sharper. So again, it's my open A, nice and steady. And that's my A at the 12th fret sharp. And you can hear it, right? If you play the harmonic instead of the open string, then you'll actually get a really close comparison. So harmonic, and then the fretted 12th fret. Sounds a little bit sharp. So what we're going to do is, so what that's telling us is at the 12th fret, when I press the string down at the 12th fret, it's pushing it sharp. So I need to make my string a little bit longer in order to compensate for that. So if your fretted note is sharp, you want to make the string longer. If your fretted note is flat, you want to make the string shorter. So I'm going to make my string a little bit longer because the note was sharp. Oops, I'm going to turn my volume back up. Bring the guitar up to tune. By the way, again, if you're having tuning stability issues, make sure you have enough wraps on the string, but also make sure you're always tuning your guitar up. Don't bring it down in pitch, bring it up. If you go too far, you're too high and you want to go down, don't carefully bring it down into pitch. Bring it way down and then come back up like that. You're putting more tension on the tuner. Just the way the gears in the tuner work, you're not introducing any slack. You'll get more stable tuning if you always tune up. Okay, so now back to that A. Pretty close, rolling a tiniest bit flat, but pretty close. Yeah, pretty much perfect. Fretted note. And now, open. Still just a tiny bit sharp, so I can take this, make this just a little bit longer, although that was pretty darn close to where I wanted it. So one more time, I just made the string a little bit longer. Tuning up again. Open note, open A is in tune. Fretted A at the 12th fret. Maybe just a hair sharp still, but that's pretty much perfect. I have a little bit more room to go back. Haven't maxed it out yet. So again, open note is in tune. 12th fret. Sitting solid. I would be okay with that even being a little fat. So that's pretty much perfect now. Again, deadly accurate tuner. It might be off by a cent or two. I would take a lot more time doing this in the shop. It's just a demo, but that's pretty much in tune. I would maybe want the string just a hair longer because, again, as I discussed on Friday, or on Thursday rather, if you have to pick, it's always better to have your fretted note just a little bit on the flat side because you can push it sharp, right? Any fretted note, you can use finger pressure to make it go sharper or flatter. All of that is just me pushing harder. I'm not bending the string, I'm just applying more finger pressure. People that play with a death grip need more compensation than people that play with a very light touch, just because they flex the string more. There's a million other things that factor into this and a lot more I could say about intonation. I just wanted to give you a basic idea of how the principle works. Now we're going to move on to electronics. Oh yeah. Oh, actually just one last thing I did want to say about intonation too. You can see in doing that, I moved our A string quite a ways back. Before you do intonation, as I talked about, always make sure the guitar is perfectly set up, that you don't have high action, that you don't have high action at the nut especially, too much relief, because that can all affect it too. But if everything else is, the fact that I had to go all the way back like this is a sign that maybe there's something else going on. So you want to check the rest of the setup and make sure that everything's perfect. But it's not uncommon, especially if you're using heavier strings or a lower tuning, it's not uncommon that you go all the way back like this and you just can't get back any further. this is pretty much maxed out all the way, but one thing you can do sometimes is you can flip the saddle around. Now this one's already flipped, but take for example the G here. You can see that the break point is forward. These three strings here, you can see that all the breakpoints are forward, whereas the bass strings, the breakpoints are actually backward. This gives a little extra length to those bass strings. So hypothetically speaking, if you were intonating the G, you brought it all the way back, you still wanted to go back further, but it can't go back any further. What you can do is take the saddle out and flip it around, and that gives you another millimeter or two. Most guitars from the factory, this is generally pretty well done and you don't have to do that, but especially if you're getting a used guitar, it's not uncommon that some of the saddles will be flipped around backwards or the wrong way, and flipping one of them around might get you that little bit further forward or that little bit further back that you need to get it intonated properly. Okay, so a few electronic issues real quick. Let's talk about crackling, busting up electronics generally speaking. Despite my best efforts, most of the guitars in here, the electronics are working pretty well. But if you do get crackling, where you're still getting a signal, you can still play, but anytime you touch a component, you get crackling, loud popping, distortion, anything like that, it's probably something going on with the component. There's two things you can try. First of all, a lot of components just get old and dusty. So for pots, for potentiometers, where there's actually, let me show you real quick actually how a pot works. It'll make more sense. I mean, this is a pot, the internal piece, and inside here, there's a little disc that spins around. So there's basically a track that's got carbon on it, and then a little disc with a contact point that swings back and forth. So quite literally, the connection is friction. It's a circuit that's being made by dragging a conductive probe along a carbon track. So there is real friction, and it's all open. And all pots are like this. They're open to the air. So they can get dust in them and stuff like that. So if you have a scratchy volume pot or a scratchy switch, start by cycling it 100 times. Especially if you don't use the guitar very often, and especially with pots, just cycle it 100 times, and a lot of times the scratchiness will go away. The number of times I've had people drive in an hour to our shop to get guitar repair help, and we've just sat there with them for 30 seconds doing this, and their problem disappeared. It's nice to be a hero, but you sure wish they didn't have to drive all the way in. So in terms of actually, let's say you try that and it doesn't work, you still have a scratchy pot. There's a good chance you're heading for component replacement, but there are a few things you can try real quick. Compressed air is always the first place to try. You're not going to hurt anything with compressed air. You can blow out components from the outside, but it's best if you actually pop off the control access panel at the back, and you can actually spray inside and just get any debris, any dust, anything like that out of there. And you can sort of come in close to the actual components themselves, but you don't need to get right down inside. So the first thing to try is compressed air. We want to go from the least aggressive thing we can use to the most aggressive. So if you tried compressed air and compressed air didn't work, next try fader lube. This is a very important distinction. Fader lube, fader lube, fader lube. This is not contact cleaner or switch cleaner. This is fader lube. It's meant for faders in a mixing panel, and it is safe to use on a control pot, a volume or tone pot. This will not strip the carbon track. It won't degrade any of the carbon components over time. It is meant to be used as a lubricant for components that slide, like a potentiometer. So this is safe to use on volume pots and tone pots. You can buy this from us. This is sold at Long McQuade. It's made by a company called Deoxit. CAIG is the CAIG Laboratories. CAIG is the actual manufacturer, and this is Deoxit Fader Lube F5. We sell it at Long McQuade. A lot of electronic stores, home audio stores sell it too, but we certainly sell it. Try this first. You can attack your pots from the outside, getting down inside a switch like this. You can just come in and spray a little bit like that. You can pop the knobs off, and you can come in around the collar of the pot a little bit like that, with a little bit, and cycle the pot a million times after you're done spraying it, and that will get it down inside. Generally speaking, that's going to get you there. You can also, too, if you want to be really controlled about it, you can actually come right inside the pot itself. Like we said, it's all open. If you can see where you're aiming, and you can actually aim right inside the pot itself and spray a little bit in there. You're not going to damage anything. I'll quickly show you that on the just a little example pot I had. Oh well, it doesn't matter. But regardless, you can get down inside where the actual carbon track is and spray this inside. If this doesn't work, then you can use contact cleaner or switch cleaner. So the truth is, this is one of these guitar techs have to give the absolute correct advice. Switch cleaner has some stuff in it that over time can strip the carbon track off of pots. So I really don't recommend you use it on pots, because while it may solve your problem today, it's only going to cause a greater problem down the road. This stuff is safe. You're never going to degrade your parts. If you've tried this and you still have a scratchy pot, you still have a bad something like that, by all means use an actual contact cleaner, and that will get you through your gig. But just be warned that long term you may be degrading the potentiometers in your guitar, and you may be shortening their life a bit more. But I certainly wouldn't knock anybody for using a harsh switch cleaner on their guitar right before a show, just to try and get out there and get it going. And it is a stronger cleaner, and sometimes it will actually penetrate where the fader lube doesn't. I found my example pot here. So again, this is a pot, and you can actually get right down inside and spray the fader lube in there and then cycle it. And then you're getting it right on the carbon track, the connection point, the main point that usually fails. Okay, so that's potentiometers, that's switches. Let's talk about output jacks. Output jacks are the most common part, I think, that fails for people. So we got a nice signal here. I'm going to position camera 3 again. So on this SG, this is our output jack coming through here. Actually, real quick, I'll just show you. This is an output jack. This is the actual part. That's what's inside your guitar. Very common, right? Here is a cable. We're going to plug it in. So this connection here that's coming out, this little arm, this is actually the hot lead of your circuitry. This is where the main lead of the signal is coming through. On a cable, the lead is in the tip here. Then there's this little insulating ring, and then the sleeve, the shaft of the plug on the cable, that's actually the ground. So in terms of an actual electrical circuit on a cable, this is the lead, this is the hot lead, and this is the ground. And they're separated by this little insulated ring. When you plug in to a jack, the connection to the tip is made by this little arm, and the connection to the ground is actually just the whole inside of the jack itself. This is all the ground connection that connects to the shaft, and the tip connects to the tip here, and then the arm connects to the tip, and then they're insulated by these little brown rings here. So in order to get a good connection, this tip needs to be making a good connection with the tip of the actual cable. So one thing you can try sometimes, if you're getting it intermittently breaking up, especially if you notice when you move the cable around that it's breaking up, sometimes this arm here doesn't have enough tension on it, it's a little loose. You can try actually just taking the cable out and bending the arm back in a little bit to put a bit more tension on it, and you'll get a more solid connection. That's the first thing you can try. Actually, the very first thing you should try is tightening the jack itself. If your jack is loose, if it's, I'll show you here on the camera, like this one is, if your jack's actually able to move around, that's a problem. You need to tighten it down. So this nut on the outside is the only thing that tightens the jack down, but don't just put a wrench on it and start spinning it. Because what will happen, if I just come in here from the outside grabbing nothing else and put a wrench on it and start to spin, on the inside, I'm going to actually start spinning the jack around, as you can see. And that's not good, because that can only go on for so long before it spins around and around and around and winds the cable up in a spiral and eventually snaps the cable. Most broken wires we see inside guitars are output jacks that were left loose for too long and were allowed to just spin around constantly from use, or from someone who tried to tighten it from the outside only and just spun it around enough until they wound up the wires and broke them. So always access the back of the output jack and hold it in place. You can touch it with your fingers, there's no harm, and just hold it firmly in place while you tighten it from the outside. So try that first. I'll show you the ways. Having a loose jack, I mean, apart from just that everything's bouncing around and generally loose, and again, this connection here between the tip and the arm is so important, you know, just everything generally, you know, being loose is not good. But another thing that can happen is the two solder points, once you actually come off of the jack, the ground, and this is the lead here, that's our hot lead that our signal is coming from. you do have exposed wire in here, and that's pretty typical on almost, you know, every guitar anywhere. So if this is spinning around, you can actually have it spin to a point. If it gets kind of stuck over in the side, things are moving around, you could actually create a situation where the ground wire comes across and contacts the lead and creates a short circuit, right? So we have a nice signal. So I'm causing that by moving this wire exactly where it needs to be. But you can see how sometimes if things are just bunched up, not sitting the way they're supposed to sit, sometimes that can be all that's going on. So if you have no signal from your guitar or intermittent, it's cutting in and out, maybe try loosening the jack, come inside, reposition it, see if there's anywhere where two wires are touching that look like they're not supposed to be touching. The two leads coming off of an output jack, the 1, 2, are hot and ground. They must never be connected. If there's any situation where they're connected, you are not going to get a signal. One last thing you can get sometimes too, it's not the case on this guitar, but a lot of guitars have black paint on the inside of the cavity here, and it's a conductive shielding paint. It helps with certain types of radio interference and so forth. It's very common that you see black shielding paint painted on the inside of these guitars. The thing to remember is that black paint is grounded. It's part of the ground circuit. So if this jack is allowed to spin around and this hot lead lug here that's carrying our hot signal, if it actually spins around to a point where it contacts the paint, the outside of the cavity, that'll be enough to short it out too. This is another one of these simple things where if you just don't know where to look for it. But we've had technicians sometimes burn half an hour trying to figure out why this guitar won't work. They're testing the pickups, they're checking the switches, they're running everything trying to figure out what's going on with it. And it turns out it's just one of the pots or the jack or something is spun, and its lead lug is actually contacting the black paint of the inside of the guitar, and that's shorting the whole system out. Reorient the pot, the whole thing works, and you're done in 5 seconds. Okay, so that's a few kind of common things you can try, a few sort of common things you can look for. I'm going to just really quickly show you how to replace a output jack. There was some questions about soldering. Soldering is a big part of guitar work, so thought really quickly I could resolder an output jack for you. Okay, I'm going to turn my soldering iron on. I like talking about soldering too. Get my camera back out here. Soldering is all about heat and maintaining heat, keeping heat high enough. It's not exactly about melting the solder onto the metal. It's about heating the metal up enough so that it melts the solder and absorbs it into itself. Heating the metal is the important thing you need to keep in mind here. You're not heating just the solder, you're heating the metal. Okay, so I'm going to replace the output jack on this Stratocaster here. I'll show you how these ones come out. So rather than a control panel in the back, it's got a jack plate in the front. And I was already taking a look at this one earlier, and this is going to be a great example for a reason why you might be getting no signal. Because if we look at this one, well, there's the jack, all the wires are connected, nothing's shorting, but what is it missing? Actually doesn't have the arm on it that is supposed to be connecting to the hot lead of your guitar cable, and there it is inside the guitar, broken off. Not too uncommon. A simple jack replacement will fix this. Okay, so let's do this real quick here. So I'm preheating my soldering iron. You should use lead-free solder. There's no reason to use leaded solder anymore. Long ago, when lead-free solder kind of first came on the scene, there was a lot of detractors. Some people didn't like working with it. It required a little bit higher heat than leaded solder. Lead-free solder has come a long way. Even in the last 10 years, let alone the last 30, there's absolutely no reason to be using leaded solder ever again. I'm going to show you my favorite tool, the third hand. It helps hold pieces for you so that you can have more hands when you're soldering. So, really quickly, looking at what we've actually got to work with here. We have a white wire, that's our hot lead. We have a black wire, that's the string ground on this guitar, and then there's also a shield coming out here, a gray, out of the gray housing, just a blank braided wire. That's actually our shield. We're going to start by desoldering all of that. Now let's see if I was smart enough to bring my desoldering tools. So we're actually pulling solder off of this. Doesn't look like I was. Okay, well that's fine, regardless. So one nice thing is to, we start with your soldering iron tip by pre-tinning it. So take a little bit of solder and melt it on. Where are we not getting enough heat here? Nope, sorry. I wasn't preheating my soldering iron. It'll only take a quick second. But all we're going to do, I'm just going to take one of these, I'm going to take these wires off, show you how to disconnect, and then quickly show you how to solder a new part. There are a few finer points to it. A lot of soldering iron. Oh yeah, how do you know what temp to use when soldering? Yes, let's see what we're set to today. We are set to 720, which is the temperature I found works fairly well for most wire soldering. You can use a lot less if you're using leaded soldering. Lead-free solder does require a little more temperature. This was the main drawback of lead-free solder originally, was that you had to use higher heat, which wasn't great for cheap components. But the components that we're using now can all take the heat, and it's not a big issue. That said, though, I mean, you don't want to keep the heat on a component any longer than you have to, especially fine components. Anything with a circuit board, you have to be extremely careful. But most of the electronics that are in guitars are real old world technology, and you don't have to be as worried as you do. Most of this stuff's made for like circuiting very fine soldering boards and things like that. I could not do this with lead-free solder, by the way. Here's a fun fact. Apparently, the thing with leaded solder, it's actually not so much the smoke. The lead doesn't actually turn into smoke, and inhaling it is no different other than you're inhaling in smoke. The problem with lead-free solder was contact with your hands. It was that the lead got in through your skin. Apparently, I'm not a doctor, but I've heard that. Okay, so first I'm going to pre-tin my tip before I actually try and take this wire apart. Rather than just come in with cold heat, or rather than just come in with raw heat from the iron, I'm going to actually get a little bit of solder on the tip quickly here, just to get a little bit of a medium that flows. And then that's going to loosen up the solder on that part, and I'm going to pull the wire away. You can, of course, do this with pliers or with any kind of third hand or something like that, just to keep your hands away from it. I'm going to put a little bit more solder on my actual iron there. So there, that's actually a good example. This was a bigger glob of solder. I'm trying to heat it up, but it's not really going. So what I'm going to do is melt just a little bit more solder on the tip. That'll speed things up. Have a little bit of a medium in between there. Basically what we're trying to do is we're trying to turn all the metal in, all the solder, all of the metal into a liquid using heat. And if you already have some liquid solder involved, that'll get it to flow a lot quicker. Ah, darn, I really wish I had my solder sucker with me. So normally in this situation, we would actually pull a bunch of this solder, liquid solder, out of here before continuing any further, but it requires a tool that I don't have. But basically we're just going to keep it heated up and work the wire out of there. I mean, you can also cut the wire off and just trim a new one. In fact, let's do that, because this is being a little cranky. So just cut it off. As long as you have lots of length, check and make sure that you're not in a situation where you're down to your last few millimeters. All right, so real quick, I'll just show you on a new jack how to solder the ground wire, just so we don't spend all day here. Hopefully we'll get some questions. If I can ever find the parts that I need. All right. Well, that was desoldering. I'll show you soldering on this CLR switch here, since I've straight up lost one of my props and can't find the output jack. So regardless, all I really wanted to show you is how to start a new solder connection. All right, so it's like when they change the actor on a TV show and just don't address it. So now we're going to solder in this switch. So let's say I want to connect a wire. I do have a nice, it's a little bit finer gauge than you'd normally use in this situation, but let's say I'm going to connect this blue wire to this CRL. I keep saying CLR, jeez. CRL is the name of the company that makes the switch, not CLR, the cleaning product, jeez. So after we strip the wire, CLR would probably be safe to use for contact cleaning though. Okay, so we're going to solder this to here. So rather than come in and tie we see this a lot where people come in and basically tie the wire in place and then melt some solder around it. What we're going to do is first we're going to pre-tin the connection. I'm going to heat the connection up a little bit. So now the connection's starting to heat up. I'm going to flow some solder onto it here. So now the terminal itself actually has a little bit of solder on it. It's pre-tinned. I'm going to do the same thing on the wire. And now, so both surfaces are now pre-tinned. Add a little bit more solder to the tip of my iron. And now I'm going to loosen the whole thing up, get it flowing again, bring the wire through, and then bring the heat off and let it cool down. Try and hold it as still in place while it cools down. There we go. That's a pretty good connection. I'm using a little steel wool thing to clean off my soldering iron tip when I have excess. You also see sponges with water a lot of the time, cleaning off the tip. The thing with water is it cools down the tip really quickly and it can start to do weird things over time. This will do the same thing cleaning your tip. You just plunge the soldering iron into it and pull it back out. It scrapes off any excess solder so that your tip's coming out clean, but it doesn't cut the heat the way the water sponge does. Okay, so that, believe it or not, I'm actually fine with. That is a really, really minimal soldering job. You notice I haven't even closed off the opening. It's pretty minimal. It's the least amount of solder that I possibly need, but it's a strong connection. From there, you can clip the tip off. You don't want to see big globs of solder. It should come out looking relatively shiny. It shouldn't look matte or clouded. Big globs of solder, when you have a big ball of solder on there, you think, oh, it's really strong. It's like putting a lot of glue on this thing to really hold it together. You know, it's got that big glob on there. But the thing is, big globs of solder, when they cool, the outside cools quickly. Well, they don't cool evenly, basically. The core can't cool quickly enough because it has so much insulation from the outside. And you can sometimes wind up with what's called a cold solder, where there's actually a little bit of space in there and it looks perfect from the outside, unless you really know what you're looking for, but it makes for a crummy connection. So less is more with solder. I mean, you should have a strong connection that's not, that's not easily going to break, but you don't, less is more with solder, generally speaking. All right, I'm remembering to take a drink of water. So we're doing okay on time. So that was replacing a jack. So the last thing I really, there's a couple questions I had that I just want to make sure I address. And then the last thing, I'm really going to quickly show you my process for fitting up a new nut on a Taylor. That's going to be super fast just because that was by request. But one question we had was, is a broken headstock on a guitar a death sentence? If I have a guitar with a crack right here behind the headstock, if the headstock is completely broken off and separated, is that a death sentence for my guitar? The answer is no. Ultimately, everything can be fixed. But it's a matter of cost and whether it's going to be worth it. Generally speaking, if you have a simple break where it's still attached, it's just a crack or a part's kind of dangling or something, all the pieces are there, it hasn't splintered a lot, it's very easy, you can kind of push it closed and it almost looks perfect. A very simple, straightforward break like that, oftentimes we can fix those for, under $300 with the whole guitar all set up and everything like that. If it's a bad break with multiple pieces, a compound fracture, especially if the break enters the truss rod cavity, you can actually see the metal of the truss rod or anything like that. Once you're getting into those, it's a lot more severe. Ultimately, anything can be fixed, but you're probably now pushing more into the $500 to $1,000 category to get that fixed and have it fixed in a way that it's going to have integrity going forward. So it tends to be an expensive proposition. And then if you want it cosmetically repaired so that it looks like it was never broken, really buckle up for in the area of $1,000 pretty much to start for most guitars. And can sometimes even be more than that. Prices, of course, vary all across the industry, but generally speaking with headstock repairs, they can always be done, and they're almost always worth it on a Gibson or an American-made Martin. If your guitar is a couple $1,000s, it's probably worth fixing the headstock, no matter how bad it was broken. If it's a less expensive guitar, under $1,000, it's going to depend how it broke. If it was a simple break, it's probably worth it, but a complex repair is almost never going to be worth it. I was asked a little bit about fret edge dressing as well. It's just a little too much to go into to really tell you your process, but I'll kind of very quickly explain it. We use flat surfaces, machinists flat edges, leveling. This is a leveling beam to actually bring down the edge of the frets and bring it down to match the fingerboard. You want to use something that's dead flat. Don't use a piece of wood. Generally speaking, you want something that's flat, that's metal. It doesn't have to be. I mean, it doesn't have to be, you know, space industry flat, but it has to. It should be something that's made for doing flat machinist things. It should be a straight edge, or it should be a leveling file of some kind. I don't ever like to use a really rough grit with fret edges. I generally start. I'll generally start with like a 300 grit diamond grit and work my way up from there. And I go up with sandpapers, usually up to about 400-600, just passing a level surface along the edge of the frets that, again, takes it down to the finish, but is light enough that when I start hitting the finish, I have lots of time between when I start hitting the finish to when I burn through the finish, so that I can see I'm starting to get close to it, and I can go up to the finer grits and really just polish everything and have it all be smooth. If you come in and try and level fret edges with something that's too rough, you're going to be just taking the metal down, everything's great, and then one pass you're going to go through the last of the metal all the way through the finish down to the bare wood. But if you work your way up with light grits of sandpaper, starting maybe 400 is a good place to start as a safe bet, then you're never going to go through the finish. There's a million finer points to doing fret edges properly, but I just wanted to say the type of tools that we generally use when we're doing that. The other thing too is Long McQuade has 80 guitar technicians all across the country, so there is a little bit of variation in technique and tools and style and approach. So you can always talk to the person locally too, and they may be able to give you a little more in-depth info than I am on exactly what will happen to your guitar when it comes into your shop. But the results should remain consistent though across the country. By the way, too, we had a little bit asking. We are, generally speaking, Long McQuade, of course, given the pandemic situation across the country, it's a little bit store by store, but most of our guitar technicians are still working. It's a job where we're alone in a workshop all day, so that is something we've been able to keep doing. It's not every location, so definitely call your store, but if you are looking for parts or if you need to get a guitar in for work or anything like that, most of our shops are still open. So call and check. For sure, because they aren't all, but most of them are still taking repairs, and it's business almost as usual. One last thing that was requested that I talked about a lot on Thursday was the Fender setup spec sheet. Fender publishes their specs for neck relief, pickup height, nut height, and action at the 12th fret. And we're gonna make that available. It's only available as a PDF, so we've hosted it on our own website, and Matt's gonna put up the link for everybody to see that, to get the Fender setup specs. These are actually, after I mentioned it and talked about it so much on Thursday, I went back and looked at it and realized, oh, at the top it said for Fender Authorized Repair Centers, confidential, blah blah blah. So oh geez, should I have been telling everybody to go look this up? And sure enough, it's not available anywhere online. But I had a nice back and forth with the head of service at Fender on Friday, and he was thrilled that we would share it with everybody, and was really excited to get that information out into everybody's hands. So there you go. It's something that Fender would normally just kind of gives to their authorized technicians, but we're putting it out there with their blessing for everybody to have a look at. Fender does some interesting things with the way they measure action, by the way. Make sure you read those paragraphs on there, because those specs, they have a certain way they want you to measure it. They've done a really good job of really kind of covering every little eventuality. Okay, so real quick, a lot of people want to replace the nut on their guitar. I'm going to really quickly show you what you need to consider to hopefully help you appreciate how much is involved in replacing a nut. A nut replacement is not a simple component replacement. You don't just get the nut that goes for your guitar and drop it in and tune it up and start playing. Ultimately, guitar nuts have to be fit. We often will make guitar nuts from blanks. We will start with a blank piece of plastic or a blank piece of bone, and we will carve every facet of it down from raw materials. However, there is a lot of pre-made parts that you can buy now. Most guitars you can buy a pre-made nut that is designed for that guitar. You can get one that's sized in a way that it's meant to work for your guitar. But that said, the pre-made thing, it only really does like 75% of the work for you. You still definitely have to do some of the work yourself if you want to install a pre-made nut. You don't have to make it completely from raw materials, but you're going to have to do some of the work yourself. Okay, so generally speaking, you would take this opportunity to change the strings and totally clean the guitar and everything. But I'm just going to loosen them quickly, put them to the sides. Now, removing a nut. On most, there's a few different styles of nut. I feel like this one is kind of a good in between. You can see it's pocketed. The fingerboard holds it in on one side, and then the rosewood headstock veneer kind of buries it in on the other side. So it really is, you have to pull it up and out. So these things are not loose in here, they're glued in. Classical guitars, they're usually loose, by the way. When you take the strings off your classical guitar, the nut falls out on the floor. That's the way it's supposed to be. They're not actually supposed to be glued in, so be aware of that. And if you have a classical guitar and you notice the nut's not glued in, don't worry, that's the traditional way to do it. But on all steel string guitars, there is some amount of glue holding the nut in. Taylor uses a very limited amount of glue, so I know that I should be able to get this thing out of here pretty easily. Now, nut replacement is almost always destructive. The old nut is going to be garbage, so we're not too worried about it, but we still don't want to cause any undue damage. So I'm going to take these end cutters here that are modified to have a really blunt center. They don't really have a cutting edge anymore. I'm going to grab onto the nut as best I can, and I'm just going to lever it backwards towards the headstock. I'll try and hold this tool in a way so you can see what I'm doing. I'm going to lever it back. You can hear the glue breaking a little bit. Starting to loosen up. I'm just rocking it back and forth. Almost there. You can just feel it loosening up. I'm just leaning that towards. We're almost out. Now I can start rocking it and lifting it up and out, and you can see it just pops right out. Now if we look at the slot where it's left, I'll see if I can get the lighting to work with me here, but you can see there's little, whoop, oh my. Yeah, that's going to be tough to see. You can see where the glue is on there, though. There's basically two little drops of glue that they put on the bottom of the nut that holds it in place. It's not a structural thing. It's not meant to take any force. It's just to keep the nut from sliding to one side of the fingerboard or the other, make sure it stays dead centered. Okay, so now I've got my nut out. So now the question is, what pre-made nut do I buy? Taylor makes it really easy because they do sell replacement parts for all of their guitars, but most guitars, when you're sizing up a nut and trying to figure out what you're going to need to buy, the measurements that you need, the main measurements you're going to need are the nut width, which is the overall width of the entire nut. Here, let me get my camera down a little bit more. So the overall width of the nut. You're going to also need the string spacing from the high E to the low E, and that's measured from the center of the string slot. That's the way that's measured. So it's possible you may have a wider or narrower neck, but the string spacing may also be different too. So you might get a nut that's the correct neck width, but not the correct string spacing. So that's important too. What do you do if some of the fingerboard goes with it? Well, I usually take that as a sign that it's time to calm down and take a break. So a few things, yeah. It can be very tough to get a nut out without doing damage to the guitar. It's a real technique thing. This came out fairly easily, but if that isn't working, you have to use a method that's going to be as low destruction as possible. So a few things. Number one, you can heat the nut up a bit. Most glues are loosened a little bit with heat. So you can actually even use it just by holding a soldering iron if it's bone. Even a light, very, very far away glance from a hairdryer or a heat gun will help loosen it up just a tiny bit. If it's really not coming out though, I recommend destroying the nut. So rather than trying to yank it out of there and taking some of the wood with it, you should collapse it. So actually get out either a Dremel or a really good razor saw, cut the nut right down the center, saw it lengthwise down the center of it, and then you can come in with a pair of pliers and crush it and just collapse it and clean it all out with a chisel. It's better to completely destroy the nut and excavate it out of there than pull it out when it's still glued to some wood and take some wood with it. There's a lot of technique here for sure. This is another reason too where we really try and avoid nut replacements on Gibson guitars, because the nut is actually lacquered over. They glue them in very seriously. They coat the entire bottom and front face of the nut with wood glue. They glue it in like a carpenter's joint, and then they lacquer over it. They really don't want you to take it out. So some guitars are easier than others. What is my opinion of graphite nuts? Do they self-lubricate? I guess I'm not totally clear on what self-lubricating is ever supposed to mean, but I think it's a very low friction material, I think is the idea. I think there is some, like the idea with graphite, I think there is actually supposed to be like kind of an oil it's impregnated with that lubricates or something. I'm not sure. My opinion is, generally speaking, you shouldn't have to lubricate a nut if it's properly cut and properly profiled. So I don't think that's a big concern. I got no problem with graphite nuts. I actually like synthetic materials more than bone. Almost all my guitars have bone nuts on them because it's a traditional thing, but there's really nothing wrong with synthetic parts. So I was talking about the measurements you need for a nut. So we need the neck width, we need the string width. It's important you have both, and then you actually need the depth of the nut. How wide is this slot here? Anytime you're doing a nut replacement, do not mess with the guitar. Do not touch the fingerboard. Remove material from the nut. You can remove old glue and so forth, but if you're trying to clean up maybe some glue on the front edge of the fingerboard, just do not touch the slot, because you can do damage that's very hard to undo. And of course, if you shorten the fingerboard even by a tiny, tiny little bit, you're going to screw up the intonation for the whole guitar. I'm going to file one of the slots on this nut slot as soon as I have it installed, just to show you how to match it to string gauge. So, okay, so I've got a couple different nuts here from Taylor, and we can even just kind of size them up in their packages. But we can see that this one, for example, is a little bit wider. It's for a wider neck guitar. This one from Taylor is the correct width. It's still just the tiniest little micron wider, but this is the correct width. If we measure this, it's a 1 3/4 inch nut. Comes out to exactly 1 3/4 on a machinist ruler. And actually, wait, sorry, I think no, it doesn't. I'm saying something that disputes with you. Oh, sorry, this is a 1 11/16 nut, so it comes up just 1/16 short of 1 1/4. And this is 1 16th, but it's just a skosh. It even says on the package actually that it's a 1 16th nut. So this is the one that we would install. Now here's the thing. And I'm going to say that Taylor generally has about the most accurate aftermarket parts like this on the market. These tend to be as close as possible, but that is not going to comfortably just drop right in. I'd have to apply a lot of force to get it to go down in. There's still a little bit of a gap there. So I need to actually size this. I need to make it a little bit narrower so that it'll fit into the slot. So the way to do that is with a hard, flat surface with a little bit of sandpaper on it. This is just a little shake of wood here that I know is flat. This does not have to be flawless, but move the part. Rather than try and like put the nut in a vise and use a file or hold something that you're trying to keep flat, it's much easier to use a flat surface and move the part. It's you're much less likely to round things over. It's a lot more accurate, and I know that I'm evenly taking material across the whole thing. So I can do that a few times until I have a nice snug fit, and I'm actually not too far off. If you want to make sure that you're evenly taking material off of the entire surface of the nut, you can just put some pencil marks on it and see, are they disappearing all over? So they're disappearing a bit at the edges, but not in the middle. So that tells me this thing is just a little bit wide at the middle. This is just kind of for your own interest in a situation like this, actually, just to see where it is. So now I'm getting a nice fit on this side, but it's still a little propped up on the other side. There's still a little bit of a gap. So while it fits in nicely there on this side, I can almost force it down, but it's still a little bit stiff. So, and then from there, so once I've got a nice fit across, Now it's just a matter of getting the string height. If I just throw these strings on, they're going to be within a mile of the fingerboard, but they're going to be way, way, way too high for any type of rock and roll. And you don't need to know a whole lot about guitars to see that something looks a little bit wrong there with just how high these are off the fingerboard. That's because you can take material off of a nut, but you can't add material on. So they always ship these things super duper high. So that's why I say it almost, I mean, outside of some unusual scenarios, it almost doesn't matter the height of the nut. If when you're measuring it, you need to know the width of the slot, and you need to know the fingerboard width and the string spacing, but the height doesn't matter because they all come really, really high. And you're going to bring it down to height the same way as we sized it into the slot, just by slowly going along the bottom. And you may need to take quite a bit off. You might want to use a heavier grit. You can use a belt sander if you're a disc sander, if you're very brave. But you're slowly going to bring it down to height like this until it's down to close to what is the right nut slot height. Because this is a pre-made nut for this guitar, I know that the slots are already radius to match the fingerboard, and that I can just drop it down from the bottom and it's going to come into being very, very close. But I don't want to do all the height adjustment that way. I'm just going to get it close that way, and I don't have time to completely take it down here, and I don't want to go too low from rushing because I want to show you how to take one of these down with a file. So once you've gotten it close, now it's time to profile each nut slot for the string. So I'm going to start tightening it up, and you see I tighten up the low E and it kind of levers the string up. So it levers the nut up. So always tighten the outside strings first because it's not glued in place. The very last thing we'll do is we'll take it off and we'll put a little drop of super glue in the middle and glue it in place. But don't do that until you're totally done and you've played the guitar and you're happy with it, because it's very easy to mess something like this up, and the last thing you want is to glue in a part that you're then having to just take out 10 minutes later. So I always leave that step till last. We're also going to clean up the edges a little bit, but again, we'll do that last because now is real make or break time, and we want to make sure we get this right before we do anything else. So, okay. So I'm going to lower one of these slots down. We'll do the low E. I'm going to lower it down. I'm going to reposition my camera a little bit here so we can get a nice good view of it. I'll show you how I do that. And before I do, though, I'm going to talk quickly about nut slotting files. Okay, so I have used every type of nut file you can imagine. Did I bring the ones I recommend? I didn't bring. Okay, so these are sold by Stuart McDonald. They're double-edged nut files. We've generally had pretty good luck with them, especially the lower gauge ones. There was a question about a good cheap set of nut files, and I've thought about this a lot, so I'll just quickly riff on nut files. We've had pretty good luck with these StewMac ones. However, the low gauge ones, the very thinnest ones, especially the 12 to 20 and the 26 to 32 ones, we found are a little bit inaccurate up and down the length of them, but it's not every file. Some of our techs, what they've actually taken to doing is like ordering 5 of each file they need, getting them in the shop, comparing them, and then keeping the best one and returning the other 4. Probably not the most advisable move. Nut files are tough. These are real precision items, and a lot of them they're doing their best, but it's tough to make a really good nut file. StewMac also sells gauged nut files, which are these thinner ones. They come in more gauges. We've generally found them to be a lot more accurate, but they're a little flimsy to use. They don't have handles on them, and especially the really thin ones, like the 10, can be really easy to break if you're not careful because they are so flimsy. And just backing up quickly, Stuart McDonald StewMac is the company I'm talking about. They're a company out of Ohio, and they're one of the best tool makers for guitar parts. They're definitely the biggest guitar repair tool company. I mean, a lot of the things they sell, don't really necessarily have to come from them, and they're so often, sometimes kind of accused of if no one else makes it, StewMac definitely makes it. We use a lot of their tools in our shops. We've had excellent results with them. They've always been a great company to work for. I can pretty much recommend everything they make, and these nut files are fine for the money. These are fairly affordable options. Another one you're going to see is the Fish Files, Yoshiko, the Hiroshima file company. They make 2 types of files. They make this set that you'll often see, this set of 3 double-edged files. These are sometimes sold under the Ibanez brand too. And then they also make these gauged single files as well. We've had a little better luck with these. We find they're generally more accurate. There's something weird going on with their manufacturing lately. Between different production runs, some of them are magnetic, some of them are not. We found the milling on some of them is not great. They're just not as sharp right out of the box, but to be honest, that's not a bad thing, especially if you're new to this. Really new, really sharp nut files allow you to do more damage quickly. So I can recommend the Hiroshima File Company ones. They're sold through All Parts, sells them. This would be one way you can get them through Long McQuade. There's a company in British Columbia as well called Japan Parts that sells some guitar parts and also sells these files. In our shops lately, this is the travel set I brought, but what is actually on my bench now, though, is a set of Valorbe files from Grobet. They're imported. And they cost like $400 for a set. So now that I think about it, that's not really a great answer for what is a good, inexpensive set of files. But that was kind of the ends of the earth we had to go to get a truly perfect set of files, I feel. The quality we've been very, very happy with there. But even there, even on those, we ordered the sizes we needed. But when they came in, we measured what size the file actually was, and we relabeled them with what they actually are. This stuff is just so precision, and the companies that make files are usually thinking about jewelry, they're not thinking about guitars, and they just don't care about the things we necessarily care about. And even for a company like StewMac, that's who's making these files, unfortunately. So is a tool company, not a guitar company. So with any files of any, I think the truth is you can pretty much buy the cheapest set of files you want, as long as you're prepared to inspect them and see what size they actually are and how well they cut, you should be good. Okay, so real quick, I'm going to cut this slot for you, and then we'll be pretty close to done here. So first of all, you want to check your string set that you put on there, and you want to know what gauge the string is. This is a 54. Very few shops have a complete set of nut files with actually every single gauge. It's really not necessary. Generally speaking, you can go, I believe Hiroshima actually says you can go up to 6 thousandths in either direction. So if you had a 56 gauge string, you could use something as high as a 62 file or as low as a 50 file. I think that's a little bit of a big margin of error, but generally speaking, going 4 thousandths in either direction is fine. So this is a 54 gauge string. I'm going to use a 55 gauge file, which is slightly bigger, but that's okay. So detune the string, bring it over to the, oh, I got to get the camera on it there. All right, so one thing I'd recommend if you do like your guitar is to mask off the area headstock just above the nut. There. Oh, that's the wrong tool for this. So mask off the area above, because no matter how careful you are, no matter how many guitars you have done this to and never nicked the headstock, guaranteed the time you don't mask it off is going to be the time that you're accidentally going to leave a little mark in your headstock that you will never be able to unsee. This is real quick. This again is one of our rental fleet guitars. I actually like to slide a little maple card or something under there that give it a really hard stop, but this is enough. Okay, so making sure I've got the right side of my file. I'm going to come into the slot here and want to make sure it's gauged for the size of string. I'm going to start filing, and I'm doing all my filing towards the back. Here, let's see if we can get the best possible angle on what I'm doing here. Yeah, the pitch is important, right? So about there, and this file, does fades away a little bit at the end, but I'm doing most of my work in the back here. You want the absolute break point to be the very front. If I paint a little bit with my pencil, I'm going to kind of show you. So that little pencil mark I just put there, that's basically the contact patch of the string. That is what we want the string to be contacting. Everything behind that really is just fade away. That should be lower. So the part that I've got blacked out should be the absolute highest point of the slot. I've got a question here. Would you use the same files for stainless steel frets? So to check your nut files, if they're true to their... well, frets don't really, we're talking about nut files, so frets aren't really a factor, but for fret files, we've had very good luck with the products coming out of StewMac. We use diamond-coated files generally, which, because of that reason, that they're safe on both stainless and nickel steel frets. Stainless steel frets are much harder. They're harder on tools. when stainless frets first kind of came on the scene, you had to be real careful about what files we're using, but for the most part, the industry's adapted and we just kind of expect it, so you don't have to worry about it as much. Oh, yeah. In terms of how measure what size your files are, how do I know? The best thing would be to use a caliper or even a micrometer if you have access to one, which I do have here somewhere, which is a machinist tool to actually measure the thickness of it, whether it's a digital readout caliper or an old analog dial caliper. Yeah, so something like this you can use to measure the actual thickness of your file. Another way to do it real easy at home is just cut a slot in anything, in a piece of wood or something like that, and then compare it to your guitar strings and see how close it is. So you can actually use the strings themselves to size it up. I think too, strings have a margin of error on them too, by the way. They can be a couple thousandths off in one direction or the other. High E string stretches by like 3 millimeters and loses like 0.5 of a thousandth of width. So again, in terms of perfectly matching the string size to the slots, a lot of time there's wiggle room all around. And this is partly why too, I like to cut the slot just a hair bigger than the string. So anyway, all right. So back to, it doesn't cause the problems people think it would. So back to this, we're keeping pitch down. So I'm going to keep filing here as I give it a nice smooth roll off. And now once I'm at a wicked angle and I know that I can't take any more off the back, I'm going to start taking a little material off the contact patch. Always go in one direction. It just gives you a much smoother and much more controlled experience that you can tell what you're doing, rather than if you're going back and forth, it's just a lot harder to see what you're doing and check your work. So I'm now starting to take a little bit off that black contact patch. Another thing too is I'm keeping the nut file itself pointed at where the string's going to go. I'm keeping it pointed at the machine head that the string is shooting for. Since the contact patch is at the front of the nut, and that's the part that I'm always keeping centered, that's what I'm focusing on, but you can aim it a little bit, and that's one way you'll prevent string binding. You can also even open up the back of the slot a little bit and actually flare it out a tiny little bit in the last little bit, just so that you'll get smooth movement. So keep bringing it down, Just taking a little more off the back. The back and forth thing is more for like profiling it in the back because you're dealing with such a small area, but when I'm actually doing the playing surface, I like to keep it unidirectional. And you can check the string height. One way that we talked about checking, just a really quick and dirty way to do it, is to depress at the 3rd fret and then just check that you have some movement there on the 1st fret. And you just keep bringing it down and keep bringing it down. All right. Make sure that the whole thing's smooth. And then when you're done, and I'm not done, that would obviously go a lot lower, but the demo is done. I like to come in with some 15,000 grit polishing paper, just super duper like ultra fine sandpaper, fold it over a couple times and just give it a quick little smooth out just to get any file marks or anything like that off of it really quickly. But when I do this especially, I don't want to touch that leading edge. Something like this is often how the break point gets moved back into the center of the nut, is someone just coming in quickly to clean it up, but accidentally taking a little bit off that front edge and moving the break point back in the nut, and then you start getting intonation problems. So if you've done everything right, you should get nice, smooth, clean string movement without a lot of pinging or buzzing or binding or anything like that. If you do want to use a lubricant on your strings, I'm not against it. I think usually if you've done everything right, but you can use a little bit of lubricant on the actual string slot. Apply it just to the front contact patch of the string slot with the string detuned, and then bring it up into tune and it'll drag it into the slot. It does help a little bit. The last step, if you've done everything right, if you're happy with how the nut's been installed, detune everything, take the nut off, just put one tiny, tiny little drop of gel super glue in the center of the nut to hold it in place. And then you can either put the 2 high strings on again and tighten them up, and that'll clamp the nut down, or you can throw a very soft clamp on there just to keep it in place, let the super glue dry for a few minutes, and then your nut is basically installed and ready to go. The last thing is just cleaning up the very edges. If you've selected the correct pre-cut pre-sized slot, pre-slotted, pre-made nut, you shouldn't have too much of a problem with overhang here. Depends how much you're going to notice it too, but if there is a little bit of overhang, again, the same 15,000 grit sandpaper, just really quickly dragging it up away from the wood of the neck will start to break that edge. If you have a gloss finish, you want to work your way all the way up through higher grits of sandpaper and up to a polish to get it looking nice and clean. But I don't recommend going too deep on trying to clean that edge up once it's on the guitar. Just use a light sandpaper to roll it over. It's one of those things people chase forever trying to get it perfectly flush, and they just end up mutilating that part of the guitar. You can get it perfect with a lot of technique, but if you're doing this at home, that's definitely something where you want to quit while you're ahead. Okay. Cool. There was only one other question that was asked last week that I didn't answer. I wish I had an example. I didn't bring a guitar to do this as an example. Oh, actually, wait, I have a question about this. I'll answer this first. Do the abrasive cord type products to remove file marks work, or is it better to use the sandpaper? Yeah, so there's a company called Mitchell's that makes abrasive cord. It's like literally thread with grit on it. It's like sandpaper but in string form. And you can use it to polish the nut slots. That stuff does work great. We have it. Works really well. It's a round shape. It's the shape of the string, so it's better than my folded over sandpaper. If you wanted to be really deluxe, I guess you could take a string that's maybe 10 thou smaller and wrap the sandpaper around it, and that way you get a rounded piece. But we're kind of splitting hairs here. The thing with the abrasive cord stuff is it only comes in a few sizes, and it's very inconsistent in its width, so you run a little bit of a risk of blowing the size of the slot. So we do have it, we use it sometimes. You know, the truth is we use it on metal parts more often. Telecasters that are breaking strings at the bridge, we'll loop it through and sand them out that way. We don't use it as much on nuts, so I think it's something you can live without. There was somebody who asked a good question about adjusting a Jazzmaster at the neck heel. So I should have brought a guitar with this type of adjustment, but it didn't come up. But when you do have a Telecaster, this one adjusts at the headstock, but when you have a Telecaster that adjusts down here at the bridge, there's a little screw in there. You can take the pick guard off, take the neck. I've seen people take the neck pickup out, trying to get in there with a screwdriver to adjust it, because there's just no room to to get in there with a tiny little screwdriver. And you see a lot of really mangled pick guards of people trying to get in there. They do sell these like really little cheater screwdrivers, like a truss rod cheater that's meant to just be really small, and you can get in there and kind of slowly manipulate the rod around, but you're still going to end up damaging the pickguard almost always. You're going to be rubbing on the surface of the pickup. It's not great. This is a great little tool. This is a good example of something only Stuart McDonald makes. So back to Stuart McDonald, the tool company. They call it a truss rod crank. I think they sell it for like under $10 Canadian. This is actually, you can actually slide in, get into the truss rod cavity and move it around. These things are amazing. We have them on every repair bench just because they're fast. Ultimately, taking the neck off, using a big, properly sized screwdriver is the best way to adjust a truss rod if you're only doing it once in a while. But if you need something to just keep in your guitar case, you show up in a new city, it's way more humid, your neck is backbowed, you have to loosen it, but you don't want to take your neck off. Little truss rod crank thing, these are great for just a quick little tweak, a huge time saver, and a tool that does not exist anywhere else in the universe to my knowledge. It's kind of like a crowfoot screwdriver, I guess. I'm not sure. Maybe some tool historian can tell me what that would qualify as. All right, cool. That's basically, I mean, I could obviously talk for a million years about the nut. I could talk for a million years about intonation, but that's pretty much everything that I wanted to say today in terms of questions that were asked that really didn't get answered. So, oh yeah, good question about cleaning strings. Yeah, so, wiping off strings after you play is the single best way to keep them from going dead. Why do strings go dead? Two reasons. They lose their elasticity over time. They just fatigue. The metal stretches out. These are elastic. Right now, the string is resting on its elastic properties, and like all elastics, they slowly get worn out. So that's one reason strings go dead, but the biggest reason that strings go dead is because they get filled up with grime and oil and sweat and just build up from our fingers, particularly in the windings, and then also the sweat and everything that sits on the plain strings can actually cause rust and corrosion. So just use a clean cloth. This is t-shirt material, a cotton cloth. Wipe down your strings soft, Don't want a lot of pressure. You don't want to press the strings down into the frets. It can be a little too much force, you know, and especially if you're sliding back and forth. So just a really light wipe down, a couple times like this, throw it back in your case. Your strings will last 3 times as long. It'll vary on the individual. It depends a bit how corrosive your sweat is. But there are some people, I mean, if you do a big, like, sweaty 3-hour concert and throw your guitar back in the case without doing this step, I don't care who you are, basically guaranteed your strings are going to be starting to rust tomorrow. But if you wipe them down, it's amazing how long they can last. So this is like the single biggest tip, I guess, that string companies don't want you to know, is you can make any string last a lot longer just by lightly wiping it down with a cotton cloth. Coated strings will last longer naturally. This step is a little less important. So in terms of actually, like, and then too, the other thing, if you have like really, if your strings have gone dead and you're about to walk out and do a song or something and you're trying to get a little more life out of them, you can actually clean plain steel strings individually with a cleaner, with a guitar polish, or with WD-40 by sliding along the plain string like that, and you can get a little rust off of it, you can get a little corrosion off of it. It makes an incredibly high-pitched squealing noise when you do it, but it does work. If you like the sound of bright strings and your strings have gone dead, you can detune them, take all the tension off, and then just bring it back up to pitch. That elasticity thing, sometimes that rejuvenates them a little bit, and you'll often will get another few songs of like nice bright sound. That's a very classic old trick. When your guitar is starting to sound a little dead and we got 2 more songs, is detune it, tune it back up again, and it'll bring some of that new string life back. I had a question. Thoughts on stringing a right-handed guitar as a left-handed? Don't do it. Yeah, don't do it. So most guitars can kind of be set up left-handed, but there's a lot of disadvantages. I mean, it's fairly obvious on electric guitars that your controls are all getting flipped around, your cutaways on the wrong side, your trem arms on the wrong side. On acoustic guitars, the issues are more so how they're actually braced. The inside of these things are not symmetrical. They have a bass side and a treble side. Things are done to accommodate things one way. So as much as the design looks basically symmetrical, and it can be done, I really don't recommend it. Buy a left-handed guitar. There's enough of them out there that you'll spend way more money chasing performance you'll never really get. So yeah, I recommend buy a left-handed guitar. There's enough of them out there. And if that's a question coming from somebody who is just starting, I would implore you to just try right-handed guitar. Try it for a couple months. If you like guitar, but there's no way this is happening, you're so dominant, you have to play left-handed, fine, get a left-handed guitar, but try to play right first. It's probably going to be fine. You think about it, they don't make left-handed violins, there's no left-handed pianos. Many left-handed people play right-handed, and man, oh man, for the rest of your life, if you learn to play left-handed, every party, every cottage, every time you're anywhere, there's going to be a guitar, and you won't be able to play it. Most of the left-handed guitar players I know have also either learned to play right-handed, or they've literally learned to play a right-handed guitar upside down, just because there are so few left-handed guitars rolling around in the world. So I'm not saying don't do it, but just understand you're signing up for a format that is not widely supported. Okay, so that's my left-handed guitar rant. That's basically it. We went over time again, but that's okay. Thanks again, everybody. This has been really fun. I'm sure I'll get back here one day and answer more of your questions. Happy repairing, and yeah, have a great spring. It's getting beautiful out there these days. Bye-bye.